Here's Edx M2 January 2010 question 4 on impulse and momentum. 8-mark question. Pause the video and make sure you're clear about what the question is asking for. Okay, so on this page I've just shown the velocity before and after the impulse. Here's before and here's after, and down here at the end, at the bottom here, is the components of impulse. So what we need is to use the equation impulse is change in momentum in vector form. So I need to write down the vectors for the velocity before and afterwards, and I've done that already. The velocity before the impulse is 30, 0. That one's easy. And the velocity after the impulse is 40 cos 60 in the x direction, 40 sin 60 in the y, which is 20, 10 root 3. So, using the impulse as change in momentum, then in vector form, we get I equals 0.25 times 20, 10 root 3 minus 0.25 times 30, 0. That's I equals mv minus mu. The momentum afterwards minus the momentum before. Now when you work out those quantities, it comes to minus 2.5 5 root 3, or in decimals minus 2.5 8.66. Now that's not quite what they want for part 1. They don't want the impulse as a vector. They want the magnitude of the impulse, so let's work that out. The magnitude of I squared is minus 2.5 squared plus 8.66 squared. And that gives I magnitude of as 9.01. Okay, and that'll be in Newton seconds is the units of impulse, or equivalently, if you think of the units of momentum, kilograms meters per second, but the usual units of impulse are Newton seconds. From the idea of impulse equals force times time. For the last bit of this question, then, we just want to find the angle that the direction of the impulse makes with the original direction of motion of AB. So fairly standard, I think. All we need to do is show the impulse. I think I've put it on here. So we've got the impulse as 2.5 back in this direction, 8.66 up here. Tan of alpha then is 8.66 over 2.55. That gives you alpha equals 73.9. So theta, which is the angle they're asking for, which is the angle with the original direction of motion, is to 3 significant figures, theta is 106 degrees. And that's it. So 8 marks in total for this. The allocation of marks went like this then. There was an M1A1 mark for the construction of impulse equals change in momentum equation. So let's put that alongside here. For attempting to do impulse equals change in momentum, for putting the right numbers in, and for then getting the right value of the impulse, that was a total of 4 marks. and rather surprisingly there was 4 marks for working out the direction that the impulse makes with the original direction of motion on here. So there was an M1A1 and an M1A1. Okay, that's the end of question 4. Thanks for listening.